Let's talk about Symfony Clock Component. When we work with dates, we often initialize DateTime objects within our code. For example, we want to set a new last updated field for our entity, and then we want to save that information in our database. In most cases, you could say that there's nothing wrong with initializing DateTime objects, because why would anyone want to manipulate dates in a different way, right? Well, there is a big side effect to this approach, and it's not obvious at the beginning. Let's say we already have a test to validate our last updated field. So for example, we initialize DateTime at the beginning of our test, then we execute our service and compare initialized date and time values to those saved in our test database. If this happens within 1 second, the test will pass because most tests are executed fast. However, as the time goes on, the code base expands, there is a big chance the execution time will exceed 1 second. Also, those tests may pass on your local machine, but when they are executed in a slower environment, the test may start to fail. As I mentioned before, it may not be obvious why they fail. What's worse, they may fail sometimes, and we are ignoring the problem by rerunning tests until they pass. This will only get worse with time, so we need to be prepared before we have loads of places where we initialize DateTime objects without thinking too much. So let's look at this example code together and see how we can solve this problem. I'm installing the most basic version of Symfony and Clock Component. I am creating an example service where I add a simple method with initialize date time object. I'm returning hours, minutes, and seconds as a string so that I can validate it later. After that, I'm quickly setting up my PHPUnit so that we can write our first test. Inside test folder, I'm adding ExampleService test with a simple test date method. What I want is to test DateTime output from our ExampleService class. So I've initialized DateTime object at the beginning of the test, and I'm comparing the output from the service. The test passed because the execution time is very fast. Now, if we simulate inside our example service 1 second delay by adding a sleep function, then our test fails. No matter what we do, it's very hard to test this logic, and we need to change the whole approach. So instead of initializing DateTime object within our method, we want to inject a clock interface into constructor. Then we can replace our initialized DateTime object for our clock service. We call a now method, and that returns our DateTime object as before. Everything else stays the same. Inside our test class, we can set our time to specific date and time. We're using MockClock in this instance, and I'm setting it to 1 a.m. in the morning. I pass my new clock as an argument to our service, and I can compare service output. By using MockClock, we are freezing time and any delays are not affecting us. We can even move clock forward at will, and in this example, I'm moving it by 11 seconds. That way, we can test a second output and we validate that the time was moved by 11 seconds. It's worth mentioning that Symfony Clock Component is implementing PHP standard recommendation document called ClockInterface. It tackles exact problem I just showed me in my example. At the same time, we should notice it's never a good idea to initialize objects inside our methods. Preferable option is to use dependency injection. It might be worth scanning your existing projects for any DateTime objects initialized and try to look at this issue while it's still in the early stages. I hope you've learned something new today. Thank you for watching, and I'll see you in the next video.